Hey guys, in this video we're going to be discussing the term computational design and really what it means to us as designers. This video is going to be part of a bigger series on this topic, so it would be great to get your feedback and questions so we can direct where all this goes. So to begin with, this is going to be a very lightweight intro overview just to clarify some terminology. So broadly, you could say that computational design uses digital tools to enhance our design processes. So in a sense, this can encompass a wide variety of ways that we use our computers in our design processes. Under the umbrella of what you could call computational design, terms that we might see or might have come across are CAD, computer-aided design, or 3D modeling, and for all you architects, BIM, building information modeling. We have parametric design and algorithmic design. Simulation and analysis comes under that or part of that. We have generative design, form finding and optimization, machine learning, and AI design. So there's a lot of gray area here and crossover between all these terms. So to get a little clearer on the distinction between them, we're going to put these into two general camps, one called computerization and one called computation. So let's start with the simpler of the two, and that is computerization. And this is a term that you might not have come across before, but you could broadly see this as using computers as purely an extension of what we can do manually. So think of an architect, his manual drawing board, a huge amount of time and effort is going into those drawings and visualizations. Any changes or mistakes are going to be time consuming and costly. CAD drawing and 3D modeling, on the other hand, is a way of extending those same skills but into a digital realm. And this creates a lot of benefits. We have time efficiencies, accuracy gains, cost reductions, automations, lots of different things. But in reality, it's the same work but just digitized. And these benefits are understandable for a relatively simple object or design process. But to design something with a high level of complexity and with a lot of non-standard elements, this is of course possible with manual drawing, just as it is with CAD drawing or 3D modeling. But even with these digitized approaches, it still can be very time consuming and costly for any changes or errors. With thousands of unique elements in some complex project, you could even go as far to say that some projects are impossible to produce like this, given that level of complexity. This is where we start harnessing the power of our computers. For very complex arrangements of objects, our computers are insanely good at keeping track of everything. With parametric and algorithmic modeling, thousands and thousands of elements and relationships can be tracked and defined simultaneously. And this creates huge efficiencies for complex design systems. And that's the key word, systems. We're creating relationships between elements, so any change to part of the system will update the whole system. Keep in mind though that all we have done is created an efficiency in our design process. We could have created the same complex designs just with a drawing board and a pencil, but this would have been very, very, very time consuming and probably shaved a few years of our life. And this is why parametric design and algorithmic design are also an aspect of computerization. They're simply extending what we could have done manually, but harnessing the power of our computers to actually make it possible. Now, our second camp is computational, and this is where things get next level. As designers, this is where we start handing over the keys to our design process directly over to our computers. And what I mean by that is in our computerization stage, we had full control over our design. The computer was just our tool. Whether we're using CAD to create 2D drawings or 3D models, or using parametric or algorithmic processes to make more complex systems, the computer is still just our tool. With computational approaches, the computer actually becomes an actively and an engaged part of the design process itself. Generative design process, for instance, could explore huge solution spaces to generate multiple design possibilities based on definitive goals and constraints set by the designer. We don't have full control over the design process, but we establish the broad parameters, constraints, and rules. For instance, we could be exploring the form of a building envelope based on weather data, physics simulations, or other external constraints. The output of this is simply something we could not have created by ourselves. The computer is not a tool anymore, it is engaged in the design process with us. An extreme of this, you could say, is the rise of AI in our design processes. We don't have full control over the imagery or the output over this, or even the system at all. But as designers, we can engage with the AI through a series of prompts, then iterate through several design loops through a machine designer collaboration. So the danger of putting things in boxes like this is that you're always going to have people say, well, what about this? What about this? Like I said, in reality, there's a huge amount of gray area between computerization and computational spaces, which is why computational design is a really good umbrella term to get a general sense of what's going on. If you want to delve a bit deeper into the academics and theory of all this, then I would suggest to start with the AD Reader Computational Design Thinking. The link for this is below. This is a compilation of essays and texts from some incredible authors and minds who have all been key to the development of a computational approach to design. It's a definite read for anyone interested. The key takeaway of all this is really to start understanding and thinking about the relationship between yourself as a designer and the tool or tools that you're using, mainly your computer. Is it just that, a tool, an extension of what you could do already with other processes, or is it an active participant in the design process itself, working in collaboration with you? Like I said, this is going to be an ongoing mini series of videos, so it'd be great to get your feedback on where to take this. In the next videos, I was thinking to extend this line of thinking out to discuss computational thinking, or what I call your computational mindset, and see how this applies to our design processes. As always, let me know what you think in the comments below, and make sure you subscribe if you're enjoying this content. Thanks very much, guys, and I'll see you on the next session.